right, so we're going to look at the last part of 6.5, and that is going to be starting out with solving right triangles. So what it means to solve a triangle is to figure out the length of all the sides and all the angles that I didn't give you. There's 3 sides, there's 3 angles, so there are 6 things you need to figure out when you are solving a triangle. But out of the 6 things, you're going to be given some of them. Okay, I have to give you something to work with. Well, based on the kind of triangles that we're solving, what do you think you're always going to have in every triangle today? Yep. You're going to have a 90-degree angle. So there's one thing you already know in every problem you're going to solve. Now, in addition to the 90, I have to give you 2 more pieces of information. Okay, there's 2 cases. I can either tell you one other angle and a side, that's in addition to the 90, or I could just give you 2 more sides. Depending on which case you have, it's going to control how you go about solving it. How come giving you both the other angles wouldn't be an option? Like if you knew the 90 and then I said, here's the other 2 angles. Marcel?
There's like an infinite amount of triangles with those 3 angles.
Right. If all you know is angles, all you can do is find triangles that are similar to it. You can't find one that's congruent. You have to know at least 1 side length to give you scale in your picture. So first case gives you 1 side length, the second case gives you 2. So some of the things that we are going to keep in mind as we're solving triangles, Pythagorean theorem is something we might be using at certain points, and the fact that all the angles in a triangle add up to 180. So those 2 facts, combined with what we did yesterday, the opposite, adjacent, and hypotenuse, Sakatoa stuff, that's how we're going to solve right triangles. What we are not going to be using today is the secant, the cosecant, or the cotangent. It's not that we can't, it's just the main reason is on the calculator. We do not have buttons for those 3. We have buttons for sine, cosine, and tangent, so we will stick with those. So anytime that we're solving a right triangle, one of the things you have to decide on is which one of those 3 trig functions is going to help you find what you're looking for. Right? And excuse me. The way you decide which one you need is it depends on the sides that you are given. If you are given the hypotenuse and you're trying to find the opposite, that would be a sine problem, because those are the 2 sides involved with sine. If you were given adjacent and you're trying to find the opposite, you've got to think, okay, they gave me adjacent, I'm trying to figure out the opposite. Which trig function has opposite and adjacent? It's tangent. So the trig function you use is determined by the sides you know and the side you're trying to find. All right, so let's look at an example. So telling us that in a right triangle, we've got one angle that's 37 degrees, and we have a hypotenuse of 8. So this is an example of the first type of situation right here. I'm giving you an angle, and I'm giving you a side. Okay. What do you think we should do first here? With all of this information, to maybe represent it in a different way. Yeah?
Draw and label a triangle.
Yeah. Every problem that we do, we're going to draw, and then we're going to label a right triangle. So there's our right triangle. And generically, we can put our labels in. This side is A, B, C. And what's the name of the angle that's across from A? Yep. Yep, alpha. And what's the name of the angle that's across from B? Yeah, beta. Okay, so that's just a generic diagram. Now I'm going to start filling some things in. It says one angle. They don't tell me which angle. It could be alpha or it could be beta. In this problem, you could pick either one. If you pick alpha to be the 37 and somebody else picks beta, you're going to get all the same answers. Your A and B are just going to switch places. That's fine. Okay. So I'm going to make alpha the 37. And the hypotenuse is 8. You don't have any choice about what letter the hypotenuse has to be. That has to be C. Okay, you've got to put that as the long side. Okay. So once I set up a diagram, that's going to help me to visualize what's opposite the 37, what's adjacent to the 37. Right? And I'm also going to make a table off to the side. And the table is going to organize all of my answers. Okay. So A is something that I need to find. So I'm going to put a box around anything that I need to find. B is something I need to find. And C was given. Okay. Alpha was given. And beta, I need to find. So when we're done, we're looking for those 3 answers. And if it's a short answer kind of question, you get 1 point for each one you get right. So you could get partial credit. Okay, what could we find first here? And you wouldn't really even need to use any trig to do it. You could just rely on maybe something you know from geometry. Yeah?
You can find beta.
Right, we can find beta. How would you get that?
You do 180 minus 90 and minus 37.
Okay, you can do 180 minus 90 and minus 37. Anyone think of an even simpler way to do it? Pretty similar, but just maybe one less step to think about.
90 minus 37.
Yeah, we just do 90 minus 37 because we know alpha and beta are complementary. So we could just do 90 minus 37, and that's going to give me 53. Okay, so now I've got beta. Any questions on how we got that one? Okay, now I need to find A and B. To find A and B, I need to pick a reference angle. The reference angle is going to be my perspective in the triangle for determining what's opposite and what's adjacent. I have 2 angles I can pick from, the 37 or the 53. Which angle do you think I should use as my reference angle? Yeah?
Probably 37.
I would use the 37. Yeah, how come?
Because you can do the sine of 37 and multiply it by 8.
Well, I mean, you could still do it with 53. We're going to use a calculator, so it doesn't really matter because of the number itself. But there is a reason why I would use the 37. Yeah?
Is it because it's the acute angle or the most acute angle?
No, they're both acute, so it doesn't really matter that it's smaller than the 53. That's not why I'm using it. Why else? What's another good reason why we would want to use the 37? Yeah?
Because it was the game.
Okay. What does that matter?
Was the information you start off with. So.
Okay. Why would you want to use that versus the 53 though? Thought we had. We were close. Yeah.
Does it really matter?
Well, it does matter. It's important. I would definitely use the 37. Anyone convince me why I would want that over the 53? Yeah?
Is it because it's adjacent to the 8?
Nope, it doesn't have to do with its position anywhere on the triangle. Where did the 37 come from? Yeah.
From the alpha?
Well, we assigned it to alpha, but how did I get it? Where did it come from? Yeah.
It was written in the top.
It was given. Yeah, it was given, which is important. Why would I want to use something that's given? Yes?
Because if it's given, you know it's right, so there must have been any other answers.
Right. I know that that answer is right. If I use beta, and I got beta wrong, then you're going to get everything else wrong. So in these problems, don't use anything that you calculate to figure out something else, because then it could be a chain reaction of getting things wrong. Always go back to what was given. And in a right triangle, you can always do that. When we're dealing with things that are not right triangles, that's a different scenario, okay? But for now, always use what was given. So that's the reference angle that I'm going to use. And what else was given besides the angle? Yeah, the 8. And that's the hypotenuse. So everything we do in this problem is going to involve the 37 and the 8. Now we have to pick if we want to do A or B first. It doesn't make any difference. So which side do we want to try to find first? Yeah, A. Okay. So what I want to do now is look at the position of the sides that I know and that I'm trying to find. Position of side 8 is hypotenuse. Okay, so we have something with hypotenuse. What's the position of side A relative to my reference angle? Yeah,
It would be the opposite.
it would be opposite. Opposite and hypotenuse. Which trig function out of the 3 that I said we're using today has opposite and hypotenuse in it? Yes, sine. So now we're going to set up an equation to solve for A. Okay, so you always have a trig function on one side and then a fraction on the other. So it's the sine of, my angle is 37, and sine is opposite over hypotenuse. So what's going to go on the right side for my fraction? Yeah,
A over 8.
A over 8. And now we have to solve for A. How do you get A by itself there? Yeah.
Multiply it on the side.
Yep. Multiply both sides by 8. And decimals are okay for these problems. So we are going to round this off, and we'll go with 3 decimal places. Okay, first thing I need to check is my mode. My angle is degrees. Right now my mode is radians. That's no good. So we're going to change to degrees. And we're going to type in 8 sine 37, and that gives me the length of A. So it's 4.815. Okay. You shouldn't have 4.816. You shouldn't have 4.814. Properly rounded, it's 4.815. All right. So now I've got A and I've got C. What could I do now since I know 2 out of 3 of the sides in the right triangle? Yeah. I could use the Pythagorean theorem, but I'm not going to do that. Why do you think I'm going to avoid Pythagorean theorem? Yeah.
So number's not exact, it's rounded.
Okay, so this is rounded, and using something that's rounded to get another answer is going to make that answer a little bit less accurate. Another reason why I'm not going to use Pythagorean theorem. Yeah, let's.
Would it just make an empty number?
Well, we're going to get a decimal no matter what we do for B. So we're not going to get a nice number. Yep, Travis.
Because it wasn't given,
So what's wrong with that?
because we could have done something wrong and
Right.
we won't get it correct.
Maybe this isn't even just rounded. Maybe it's the whole wrong number. Okay, so if it is a wrong number and you use it to find b, then b is wrong. So it's going back to what I said before. Don't use anything that you calculated to then figure out something else. So what we're going to do now is visualize again what sides we're using. Still using the 37, that was given. Still using the 8. But now I want to find b. What is the position of side b relative to 37?
Adjacent.
Adjacent. Now we're using adjacent and hypotenuse when we try to solve for b. What trig function has adjacent and hypotenuse in its definition? Yep.
Cosine.
Cosine. So we can set up the same kind of thing. In the trig function, you always fill in your angle. That's the 37. Shouldn't have anything but a 37 as your angle in this problem. And then adjacent is b over hypotenuse is 8. Whenever the variable ends up in the top, all you have to do is multiply both sides by the number at the bottom. And that is your answer for b. 8 cosine 37. Okay, so 6.389. Now, if you have extra time and you want to try to check that, you could plug that into Pythagorean theorem and see if it comes out close. You could do a squared plus b squared and see if it comes out to about 64. It should. Probably come out to like 63.99 or 64.001 because of the round. Any questions on how we solved that triangle? Let's try another one. So this time, no diagram, or no sentence describing what's happening. They're just giving you the information in a very succinct way. Alpha is 20, A is 12.3. All right, so what's the first thing that we always do when we are solving a triangle? Yep.
Draw a model.
Draw it out. Okay, so we're gonna make a sketch. What's the relationship between A and alpha as far as their position to each other in a triangle? Let's.
Would A be opposite of alpha?
A is opposite alpha, so you can put A and alpha wherever you want. Just make sure they're opposites. So I'm going to put A over here. I'm going to put alpha over here. Well, this side is A. That means the bottom side is B, which means that angle up there is beta. And this side is C. Okay, so there's my diagram. Now I'm going to make a table just to put all my answers into. Well, you always have one answer right away, the right angle. So that's a 90. The alpha was given. And A was also given. So you need B, C, beta. All right. You can find anything you want in any order you want, but I tend to do the angle first because it's usually pretty fast. What's beta going to be? Rush? 70. Yep. Are we going to use the 70 as our reference angle in the problem? No. We're going to use the 20. Because we know it's right. So we're going to stick with the 20 and 12.3. Which side do we want to do first? B or C? Doesn't matter. C. So now figure out the position of the sides that you know and that you're trying to find. What is the name of the side that's 12.3 units long? Or what's its position in the triangle? That's opposite. And the side that we chose to find is C. What's the position of side C? Yep, hypotenuse. So now when we solve for C, which trig function has opposite and hypotenuse in it? Yep, sine. So can you set up my equation for me?
Sine of 3 equals 12.3 over 6.
Yep. Now it's a little different because this time we've got the variable in the bottom. So first thing I want to do is just try to get rid of having a fraction. How would I get rid of the C in the bottom of the fraction? Yep. Okay. Multiply by what?
Both sides by C.
Yep. Multiply both sides by C. Now I have that. And now how would I get C by itself on the left? Yep. Divide by sine 20. So in the future, what I'm going to do is I'm just going to take these two and swap them, because that's all that happens every time. It ends up swapping. If you don't want to swap it, then you can go through the steps we just did, but you're going to end up with the same answer. All right, let's type that in. 12.3 divided by sine 20. I had an extra parenthesis that I didn't need around sine 20. It's okay. It's 35.963. And do I need any kind of label on that, like degrees or radians? What did I just find? Yeah. I found a length. I didn't find an angle. Okay? We already found the angle earlier. Okay? That's 35.963 units long. All right, and let's finish up with B. Can anybody tell me which trig function that I'm going to use to find B? Yep. Yep. And can you set up the equation for me with tangent? Yep. 12.3 over B. So if we use the same trick I just had before, B equals 12.3 over tan 20. So let's type that in again, except change our trig function to tangent. And we get 33.794. Now, a couple things always have to happen when you solve a triangle. The biggest side should always go with the biggest angle, and the smallest side has to be across from the smallest angle. If that didn't happen, something is very wrong. The other thing that has to happen with the sides is in a triangle, any two sides added together need to be bigger than the third. So if you add A and B together, they need to be bigger than C, and it is. B plus C has to be bigger than A. Yep. And A plus C has to be bigger than B. Okay. If you add two sides together and they are not bigger than the third, something is wrong. So you can never have a triangle of like sides 1, 1, and 200. That's impossible. The other side's too long to make the other ones connect. All right, any questions on that one? All right. So now let's look at the other case where they start us off with two sides. This is still doable, but it's going to be a different approach than the way we did the last two. A little bit different. So this time they're telling us one of the legs is 12 point, the hypotenuse in one of the legs measure 12.7 and 6.1. Well, if they're giving us two numbers, and we know one of them is the hypotenuse has to be the bigger one. So the hypotenuse must be the 12.7. Okay. What do you think our first step is going to be here? Yep.
Draw a triangle and label it.
Yep, we're going to draw it, and that's purely so we can visualize opposite, adjacent, and hypotenuse. Okay, when you've done enough of these, you start to get really good and kind of visualize some of it in your head. But I would recommend making a sketch. It only takes like 10 seconds. All right, so we've got hypotenuse is 12.7. I know that's side C. Okay, the other two sides are A and B. Doesn't matter which one is the 12.7 because they didn't say. They just said one leg. So make A 6.1. That's alpha. That's beta. Okay, off to the side, we'll make a table. Okay, so we know A is 6.1. And that was my choice. I chose to make A the leg they gave me. I could have chosen B, and it would have still come out okay. Your alpha and beta would just switch places in your table. You get different answers. B we don't know, but C we know is 12.7. What else? A, alpha, and beta, we don't know either. Okay. So, any suggestions what I do first here? Yep.
Find beta.
Okay. How are we going to find beta? We got to use two sides. What are the two sides you're going to use?
The adjacent and hypotenuse.
Yep, we're going to use the adjacent and the hypotenuse. Okay. So those are the two sides. Okay, so we've got the two sides, and can you tell me the names of those two sides again? Because you said you're finding beta, right?
Yeah.
Okay, so that's our reference angle for this problem for now.
Yeah.
So this is which side?
Adjacent.
Adjacent. And what about this side?
Hypotenuse.
Hypotenuse. Okay. Which trig function involves adjacent and hypotenuse? Yeah. Let's. Tangent is opposite and adjacent. There's no hypotenuse.
Oh, I
in
mean
tangent.
cosine.
Cosine, yeah. Okay, so let's find beta. And we're going to use cosine. Okay. What am I going to fill in for my angle? Yep.
Can we use 90?
Nope. Can't use 90.
Yeah. Beta.
Beta. Okay, everything is from the perspective of your reference angle, and your reference angle has to be an acute angle. It can't be the 90. So cosine beta. And what's going to go on the right side? Yep. 6.1 over 12.7. All right, now this one's a little different. You've never had the variable inside the argument to the trig function. It's always been in the fraction. So what we have to do now is get the beta out from inside the cosine function. It's kind of like if I gave you something like this, and I said, how are you going to get the x out from inside the square root function? No amount of adding, subtracting, multiplying, or dividing is going to get the x out of that square root function. How do you get the x out of the square root function? Yeah, you would square it. The only way to get rid of this function is with another function. And we have to use the function that is going to cancel out the one we're trying to get rid of. So we had a square root, we used a square function. Those two functions are what we call inverses of each other, squaring and square rooting. Well, we're going to have to do the same thing here. We need to get rid of this function to get that letter alone. We've got the cosine function. Does anybody have a guess what function I'm going to use? We've never mentioned it before, but we're going to now, to get rid of cosine. Yeah, CJ. That's the reciprocal function. Yeah?
Is it like rose raised to the negative first power?
Well, how do you think you would pronounce that?
Cosine inverse.
Inverse cosine. Yeah. So we're going to use what's called the inverse cosine function to cancel out the regular cosine function. And I think I wrote some of that down. So right now we used a different letter, that's fine. We're at that step. And to cancel out the cosine, we have to use inverse trig. Okay. That beta is not being multiplied by cosine. Just like here, you wouldn't say that this x is being multiplied by this root symbol. No, there's no multiplication. Even though these two things are right next to each other, this is a function. That's a variable that's inside. Same thing here. This is a variable that is inside the cosine function. It's not, there's no multiplication on the left side of that fraction. So we're going to use inverse trig. The way that you write, there's two ways you can write inverse trig. On the calculator, you're going to see a button that says the trig function to a -1 power. An older way of writing it is arc sine, arc cosine, or arc tangent. So anytime that you see arc in front of a trig function, it means what's right next to it, the trig function with a -1. Now the -1 is written in a spot where you would normally see an exponent, but that -1 has nothing to do with being an exponent at all. The -1 in a position that's a little bit higher than the trig function is just a symbol that means inverse. That's all it means. Okay? But what is a little confusing is when you write a trig function and you put a number there that's not a -1, it is an exponent. So this does mean sine times sine. Right? So the -1 is kind of a special case. It's just a symbol that means inverse. All right. So when we've got a problem where we're trying to get rid of a function, we have to be careful about how we say it. Say I had this problem, and I'm trying to get rid of the squaring function. How would you explain what to do in this one? I'm looking to make sure we say it properly.
Yep. Square root both sides.
Okay, can you say it again?
Square root both sides.
Yeah, we're gonna take the square root of both sides. You wouldn't say multiply both sides by square root. You never say multiply, add, subtract, or divide when you're trying to get rid of a function. The correct word to use is take the square root of both sides. Same idea with here. To get rid of the cosine, we are going to take the inverse cosine of both sides. So we're going to do this. We're going to take the inverse cosine of everything on the left. And we're going to take the inverse cosine of everything on the right. So I wrote down in red what's new in this step. 6.1 over 12.7. Now, when you take the inverse cosine of the cosine, it's like taking the square of the square root. What's going to happen? Yep, they cancel out. What's inside the function doesn't cancel out, just the function itself, the square and the square root, or the cosine and the inverse cosine. So what you're left with is beta equals, and then you have a calculation you need to do out. So on the calculator, we're going to type in inverse cosine. And the way you get to inverse cosine is you press second cosine. Second, and then a trig function will give you the inverse. So inverse cosine of 6.1 over 12.7. And that gives us 61.294. And what did we just solve for? Yep. Beta, which is an what? It's an angle. So we need to make sure we put the proper label on it, which in this case is degrees, because my calculator is in degrees. 61.294 degrees. Okay. Now, we're not going to add beta at 90 and subtract from 180, because if beta is wrong, now you're going to get alpha wrong. We're going to find alpha the same way we just found beta. Find alpha. All right. So now we are switching our perspective. We're switching the reference angle. So we are now standing over here, and we're using this, and we're using that. That name doesn't apply anymore. 6.1 is now in what position relative to alpha? Yeah, it's now opposite. Hypotenuse is still 12.7. That doesn't change. Right. But now we're using the opposite side and the hypotenuse. Which trig function involves opposite and hypotenuse? Yep, sine. All right, so let's find alpha. We already know what we're filling in for the angle. That's alpha. And what's going to go on the right side of my fraction? Or what's on in the fraction? Ethan, can you tell me what goes in my fraction? Jane? 6.1 divided by 12.7. Yep. And how am I going to get alpha by itself there? Yep.
Just do the inverse function or something.
Okay, can you say it?
Just do inverse sine.
Yep.
Both sides.
And what are we doing with the inverse sign? We are not multiplying. Never say multiplying when you're dealing with canceling out a function.
Because you're taking.
Taking,
those
perfect.
that
Yeah.
inverse sine.
Yep, we are taking the inverse sign of both sides. Okay, there is no multiplication happening there. Just like when I do this. I am not multiplying both sides by the square root. I just took the square root on both sides. There's no multiplication. Okay, so take the inverse sine of what's on the left. Take the inverse sine of what's on the right. Inverse and regular sine cancel, and you're left with the inverse sine of 6.1 over 12.7. Let's change our trig function. And we get 28.706. Okay. And you can double check. You could add them all up and make sure they add up to 180, or within a thousandth of that. Because of our rounding, it might be a little bit off. Okay, what do we still have to find? There's one more thing. Yeah? B. How am I going to find B without using any of the work we just did? Because if that work is wrong, I don't want to use it. Yeah? Right. I can use Pythagorean theorem because everything I'm going to fill in was given. Okay, so to find B, we're going to do 6.1 squared plus B squared equals 12.7 squared. So if we solve that whole thing just by rearranging it, we're going to have 12.7 squared, subtract the 6.1 squared, and then we would have to take the square root to get rid of that exponent of 2. So that is our answer for B, and I'm going to type that all in one step. Okay, it's better to rearrange it rather than like square 6.1 and then round it, and square 12.7 and round it. Then you're doing too much rounding. Okay, so try to solve it without using the calculator to just manipulate it, and then plug everything in one step. All right, so 12.7 squared minus 6.1 squared. Okay, we get 11.139. Any questions on that? Okay, so that's the other type, where you start with two sides. Anytime you start with two sides, you're going to have to use inverse trig. There's no other way to do it. Anytime I start you with a side and an angle, you will never need inverse trig. I don't want to do this one. I just want to know, would I use inverse trig? Or no, don't use inverse trig. Which one? Yeah?
I use it.
We're going to use it because we only have two sides. So you're going to use inverse trig, and you're going to use it twice to get the two angles. And you're going to use Pythagorean theorem to get the side. All right. So when we did... So this is going to be the connection between what we did before with the unit circle and what we're doing now with the opposite adjacent hypotenuse. When we did unit circle trig, what did we use as the size circle? What's the radius of a unit circle? 1. Okay, we did everything with a radius of 1. So essentially, we were making a triangle like this in the unit circle. And that is what we were using. Okay? This side was a 1. This side was an x. That side was a y. Any question on that? Now, if we want to look at a circle of any size, we can use what we just learned this week to do unit circle trig, but it doesn't have to be radius 1 anymore. What's the connection between those two purple triangles? Yeah?
They're similar.
They're similar, right? They're similar triangles. The difference is one of them is just a larger version or smaller version of the other. This time, this side is now r. It's not a 1 anymore. So when we had our definitions for sine, cosine, and tangent, let's see if we remember what they were. You had to find a coordinate. And what was the definition of sine on the unit circle?
Y.
Sine was y. Cosine? Yep.
X.
X. And what was tangent? Yep. Y over x. And the other three were the reciprocals. Well, this isn't a fraction, neither is this one. How could I make those two fractions so I can flip them? Yep.
You get y over 1 and x over 1.
Yeah. So make it 1 over y, 1 over x, and x over y. Well, this 1 that you have in the formulas here, it's not just random. That 1 is that 1. That's why there's a 1 in all of those formulas. When we do this on a bigger circle, the only thing that's going to change in these formulas is these aren't going to be 1s anymore. What do you think they would be? Based on what I drew on the right-hand side. Yep.
R.
It'd be r's. Yeah. Whatever r is. Yeah. So now, instead of the sine being y over 1, it's going to be y over whatever the radius is. If the radius is still 1, then yeah, it's just y. But if it's not 1, it's different. The cosine, instead of being x over 1, is now x over r. And what about the tangent? I think the tangent will be, yep, it stays the same. The tangent and cotangent are the same formula. Yep. Okay, and your cosecant is r over y, your secant is r over x, and your cotangent is x over y. So now those are the 6 trig functions on any circle, right? Because all we're really doing on a bigger circle is dealing with a similar triangle. That's what I'm trying to show you here. Right? And if you think about, well, how does that connect to opposite and adjacent and hypotenuse? Pretend like that's your reference angle right there. Sine is opposite over hypotenuse. That's why it was y. Cosine is adjacent over hypotenuse. That's why it was x. Tangent is opposite over adjacent. That's why we said y over x. So the definitions we had when we did the unit circle are really the same exact thing as opposite, adjacent, and hypotenuse. Okay. Any question on that? So those are all the formulas again, if you want to write them down. So sine, cosine, tangent, cosecant, secant, and cotangent. Okay, so let's see if we can find the 6 trig functions of the point 2, 3. Okay, is 2, 3 a coordinate that we saw when we did unit circle trig? Is that a coordinate that came up? No, we had coordinates like root 2 over 2, root 3 over 2, 1/2. 2, 3 is not a coordinate that ever came up. So if we look at what we're doing, let's make our grid. We've got a circle where that's on the edge of the circle. 2 units right, 3 units up. 2, 3. Imagine you put a circle through that point. Does that circle that I just drew have a radius of 1? No. So it's not on the unit circle, which means to do this problem, this is your x, that's fine. This is your y. So you can do any of the formulas that just have the x and the y. But if you want to do the other ones, you need the r. How are you going to find the radius of that circle? That's the radius. Yep.
Pythagorean theorem.
Yeah, we're going to use Pythagorean theorem and basically make a right triangle. The base of this triangle is 2. The height of the triangle is 3. What would be the hypotenuse of the triangle as an exact answer? Yep.
Square root of 13.
So 9 plus 4, square root of 13. Now you're all set. You can plug those numbers into these formulas. I'll just do the first 3. Sine is y over r, so 3 root 13 over 13. Cosine is x over r, so 2 root 13 over 13. And tangent is y over x, 3 over 2. Or if you think of tangent as opposite over adjacent, it's exactly the same thing. Here's your reference angle right here, opposite over adjacent. So unit circle trig and the SOHCAHTOA stuff, it's 2 different perspectives for doing the exact same thing. They're not different. Now, let's figure out how big this angle is right here. What do I have to use anytime I want to find the size of an angle? And we've done it a couple times today. What do you use when you're calculating the size of an angle? What kind of trig? Yeah?
Inverse trig.
Inverse trig. Have to use inverse trig. Now, we've got a bunch of equations here that we could solve for theta. Any one of these equations, and if I did the other 3, any one of those, would be enough information to figure out the size of this angle. The one that I generally use is the one that has sine in it. So sine theta equals 3 root 13 over 13. How am I going to get rid of sine and get theta by itself there? Yeah.
Take the inverse sine of both sides.
Yeah, I'm going to take the inverse sine. And it's easier if I just type it in as 3 over root 13. It's less stuff that I have to type in. 3 divided by square root of 13, which is the same thing I have there, but I fixed it so the root wasn't at the bottom. Okay, and when I hit enter, I get an angle of 56, we'll call it 56.31. That is the size of the angle in this diagram, 56.31. So just because you have nice side lengths doesn't mean you're going to have nice angle measures. They might come up to decimals. Now, when we solved for that angle, it was in quadrant 1. So all we had to do was basically take the inverse sine of our angle. But what would have happened if we had the same triangle mirrored like that. Okay. When you solve, you would still get 56.31, but the 56.31 would be that, because it's reflected. When they're asking you for an angle, they're going to want to know that. So what do you think you would do if you knew this part right here to get that part right there? Yep.
Subtract the value from 180.
Exactly. You would subtract that, what we call the reference angle. And if you're doing it in degrees, yes, subtract it from 180. Or if you were doing it in radians, you would subtract it from pi. Okay. Now, let's say you had the same problem again. But let's say that it was in quadrant 3. Here's your triangle. If you do inverse sine, you're going to be solving for this angle right here. That will come out to 56.31. That's called your reference angle. But what they're going to want to know is that. If you knew this, how do you think you would get that? Yeah. You'd have to know that to do that part. Then you could subtract that from 270, but you don't know that.
180 plus that angle?
Right, it's halfway around plus whatever amount your reference angle was. So that's in quadrant 3, if you're trying to find the entire angle, you find the reference angle, and the reference angle always has to be a positive number. That's why I put absolute values around the inverse sine, just in case it came out negative. Now let's look at quadrant 4. Here's your triangle again. This is your reference angle. The reference angle is always the one that's positioned right near the origin. If you knew this, how would you find that? Yeah.
360 minus that angle.
Right. It's all the way around except for this part. So you take that part back from 360. And that is how you find your fourth quadrant angle. So those are formulas for figuring out the entire angle when you know the reference. We're going to do more with that later on, but for now it's just important that you have this copied down. Quadrant 1 is the easiest because the answer you get, you're done. But all the other quadrants, you have to adjust your angle the way that I just showed you. So that is the homework for tonight. I'm not going to have time to put the test topics up before you leave, but I will pause it and I'll put them in the video for you to check out